Okay, so we need to bring a little bit of context into the table. So our world has been shaped around and developed around one main energy source, which is oil. And it has been like this for centuries now. And although it has brought great economic prosperity and development, it is not exempt from many issues that still make these energy source not really adequate for today's world. So this energy source is very pollutant, not only when extracted from its deposits, but also when using it. It releases a lot of harmful particles that stay in the atmosphere and in the environment and can cause severe damage to ecosystems and also to human health. And it also generates a lot of greenhouse gas emissions when combusted. Many nations around the world have started a an effort in order to reduce the use of oil in the industry and in transportation of people and goods. And they've targeted renewable sources and clean energy sources as the replacement for oil and other fossil fuels. And in this presentation, we will dive into different types of renewable and clean energy sources that can be used to replace oil and other fossil fuels.
Both. My name is Leopoldo, and after the investigation we did, we found some alternatives to fossil fuels. Um, some of them, which are solar cells, which a solar cell is a device mainly composed of silicon, and their primary function is to convert the energy of the sun into electricity. And these solar cells are the main component for solar panels. Okay. Well, as I said, they work by converting sunlight into electricity throughout a process called photovoltaic effect. Uh, a little bit explained with this effect is when sunlight hits the solar cells, uh, in, it knocks and loses the electrons from the silicon atoms, creating an electric current. That way, it will be converted to electricity. Also, it will be converted because the metal contacts of the solar cells capture this current that is created, and this allows it to produce the electrical power. Some pros of this alternative are they are renewable, of course. They also reduce a carbon footprint and lower your electricity bills. And some cons of this are the initial cost is high of the installation of the panels. There's intermittency due to the weather, okay, and also you require some space for the panels to be installed. Our next alternative is galvanic cells. These cells are electrochemical cells in which a redox reaction occurs and generates electricity. These reactions are separated into two half reactions to help balance the equation and determine the reducing and the oxidizing part. The parts of the galvanic cells are electrodes, electrolytes, and the salt bridge. In a cell, how it works in a cell, a zinc electrode is placed in a zinc solution, which is the anode, and a copper electrode is placed in a copper solution, which is the cathode. Once the salt bridge is connected between these two solutions, the oxidation process starts, and the ions travel from one cell to another. Um, and some pros and cons of this. Well, the pros are they last for very long, and they provide a steady flow of current. And some cons of this are it's expensive, and it cannot be recharged, and requires an extra maintenance for the process.
Hello, my name is Jimena, and well, what's the last alternative to fossil fuels? we have fuel cells, which are electrochemical reactors that generate clean and efficient energy from chemical energy. These devices are very versatile as they can use a wide variety of fuels and are able to provide power for large and small systems alike. They work a lot like batteries, however, they do not need to be recharged. They're able to function as long as fuel is supplied to them, and well, they consist of two electrodes, the anode, which we know is negative, and the cathode, which is positive. And both of these are separated by an electrolyte. So, some of the pros of this fuel is that creates clean energy. It's also very high efficiency because it also creates continuous power supply. However, some of the cons are the infrastructure requirements. It's also hard to store hydrogen and to produce it, which makes it quite high cost. Now, getting to the lab work objectives. So, we first have to understand the key concepts and elements of an electrochemical cell in order to theoretically design an experiment to carry it out. We also have to have a knowledge of the methods needed in order to measure the voltage of each element and also the total voltage in general. We have to research the standard reduction potential of the most suitable compounds in order to choose one for our situation. And we must create a proposal for the experiment design with its components and their respective reactions.
Good morning, teacher. I am Marcos Lopez, and I'm going to present the method of construction of this cell. So, first of all, we had to use these materials. We need the copper metal that worked as a cathode and the zinc metal used as anode. We had to put some conductive wires in order to be able to measure the voltage and the current, the resistance. We needed a salt bridge. This for the transport of ions between cells is really essential. The electrolyte solutions that well we used for copper, copper sulfate, and for zinc, zinc sulfate, and basically two containers, two beakers for each cell. Then we the steps that we take is to prepare the solutions. One side, well, the copper sulfate, as I said, and the zinc sulfate, adding the metals, the copper and the zinc, depending on the solution. We connect the electrodes. We add the salt bridge too, and finally we measure the voltage using the multimeter and the resistance or the current. As a result, copper gained electrons, and the copper ions became solid copper as a metal. The zinc, on the other hand, loses electrons and becomes zinc ions. So the overall reaction is one below. As I said, the copper ions became copper solid, and the zinc metal became zinc ions. Really simple. Using the standard potential reduction potential formula, we can have, or we can know the total voltage the cell is going to have. So in this case, the 0.34 volts of the copper minus the negative voltage of the zinc give us the overall voltage as 1.10 volts this cell can have. So the voltage over the time will decrease because energy is not forever. So the electrons are there are going to be less electrons to pass until it finish all the electrons and the electrons. We can also increase the concentrations for higher voltage. We can increase the reactants using reactants with higher standard reduction potentials. We can alter the temperature for a higher voltage or a lower voltage. We can also add more cells as we did in the class with the toys. Adding more cells adds more voltage. And in the case of the current, we can reduce the resistance in the circuit, and also we can use electrodes with larger area, sorry, or use more concentrated electrolyte solution for the current to be small. So that's all.
Hello, my name is Romina Lopez, and I'm going to be presenting the conclusions and the recommendations of this presentation. The renewable resources mentioned before share the common benefit of producing clean electricity, reducing the greenhouse emissions, and reducing the environmental impact compared to the burning of fossil fuels, which is the normal way of producing energy from cars and houses and fabrics and stuff like that. Solar, fuel, and galvanic cells offer sustainable alternatives that do not deplete natural resources and contribute to a healthier planet for future generations as well as for our generation. Their adoption can significantly reduce air pollution and dependence of finite fossil fuel reserves, leading to a more sustainable and environmentally friendly energy landscape. The use of these renewable energy sources could revolutionize energy production, reducing air environmental impact and enhancing sustainability. Transitioning to solar fuel and galvanic cells is recommended for a sustainable future. Implementing solar panels on rooftop, utilizing fuel cells for backup power in critical infrastructure, and using galvanic cells in various applications can be the first step into this transition. Government initiative, public awareness campaigns, and technological advancement can further facilitate this shift.